Hello. This next session is on artificial intelligence and medicine. I'm going to assume this audience is probably more medicine and less artificial intelligence, so we're going to structure it to sort of, with that assumption. I'll get closer. And this part I don't need to tell everyone, but the research in medicine and the application of medicine obviously is going through an enormous growth of complexity, the sheer amount of data, all of the different disciplines that need to be integrated. And I think Hiraki will talk about this a little bit in his talks. I hope not to steal too much of his points, but I think he was saying something once that there are about 1 million papers in life sciences now a year. So you've sort of exceeded the capacity for a human being to literally read all of the papers. And what's interesting, and at the Media Lab we work a lot now in life sciences and biology, because we're also finding one of the things that we do at the Media Lab a lot is build tools and think about things in different ways. And what's amazing is really, whether you're talking about the research or the diagnostics or the therapeutics, the number of different disciplines and the number of different tools that are now coming to bear on this discipline. And at the Media Lab we call it sort of an anti-discipline, when you are no longer able to contain it in a discipline. And I think one of the most interesting tools that we have available to us to both manage and understand, in quotes, this explosively complex field is through artificial intelligence, and a lot of us like to call it machine learning. And artificial intelligence is a funny word because it's been around for a long time. Danny's mentor, Marvin Minsky, was talking about it before many of you were born, probably. We'll talk about the different categories, but artificial intelligence encompasses a whole range of things where when it feels like computers are thinking. The stuff that you see really being applied effectively the most these days are a relatively narrow set of tools that we would call machine learning, whether we're talking about self-driving cars or the ability for Google to provide search results. But these are things that where machines take lots of data and are able to make some sort of sense out of it, or to be able to give you some sort of answers to questions. We'll describe a little bit about the different categories. There definitely are more, so computers are getting better and better at answering questions where lots of data is involved in figuring out the answer. And it kind of feels like magic because human beings aren't particularly good at it. There are other things like computers asking questions, which we'll talk about, which is a little bit harder. And the more it becomes something that human beings are good at, it turns out it's often that computers aren't as good at. And so one of the things we want to talk about a little bit, or be the focus of where we're going to end up, is sort of the role of machines in medical research, and sort of by extension, the role of human beings in the research of medicine. And so what does the scientist of the future look like? What does the machine of the future look like? What's the time horizon of that? And we want to give you some examples so you can get your head around it.